Assalamualaikum viewers. Today we will talk about multiplexing and demultiplexing in this video series. So, in computer networks, multiplexing is a method by which multiple analog or digital signals are combined into one signal over a shared medium. Purpose is sharing a scarce resource. For example, in telecom, several telephone calls may be carried using single wire. The transport layer in the receiving host does not actually deliver data directly to a process, but instead to an intermediate socket. At sending host, the job of gathering data chunks from different sockets, encapsulating each data chunks with the header information to create segments, and passing the segments to the network layer is called multiplexing. At receiving end, the job of delivering the data in a transport layer segment to the correct socket is called demultiplexing. Here's a pictorial view of multiplexing. Multiplexing at sender. Handle data from multiple sockets and add transport header, later used for demultiplexing. And multiplexing at receiver. Use header input to deliver received segment to correct socket. How demultiplexing works. Host receives IP datagrams. Each datagram has source IP address and destination IP address. Each datagram carries one transport layer segment. Each segment has source and destination port numbers. Host uses IP addresses and port numbers to direct segment to appropriate sockets. Connectionless demultiplexing. Created socket has host local port number, that is datagram socket my socket equal to new datagram socket, and example is 1 2 3 4 5. Recall, when creating datagram to send into UDP socket must specify destination IP address and destination port number. When host receives UDP segment, host will check destination port number in segment and direct UDP segment to socket with that port number. IP datagram with same destination port number but different source IP addresses or source port numbers will be directed to same socket at destination. Connectionless demultiplexing example is given. Here is datagram socket, new datagram socket 9157, and at the other end new datagram socket 5775, and datagram socket new datagram 6428. So P3 is, in this case P3 is source and destination is P1. Now now in this scenario P1 is source and P3 is destination. Here source is P1 and P4 is destination, and the next scenario P4 is source and P1 is destination. Connection oriented demultiplexing. TCP socket identified by port tuple, source IP address, source port number, destination IP address, and destination port number. That was about UDP, and now in TCP we have destination IP address and destination port number, and source IP address and source port number as well. So demultiplexing. Receiver uses all four values to direct segment to appropriate socket. Server host may support many simultaneous TCP sockets, each socket identified by its own port tuple. Web servers have different sockets for each connecting client. Non-persistent HTTP will have different socket for each request. We have already studied about non-persistent HTTP in previous lectures. So, connection-oriented demultiplexing example. In the first example, P3 IP address is also given, source IP, and as well as the port address. So B is source IP and port is 80. Destination has destination IP is an A and port number is 9157. So example, three segments are destined to IP address B, destination port 80 are demultiplexed at different sockets. Threaded server. Thank you very much. This is all about the data this lecture, and please subscribe our channel for further videos. Thank you.